Hello everybody, this is Mr. Ainsworth. We're going to get into section 9.1 here in integrated. We're going to talk about how to add and subtract polynomials, combine like terms. We're going to talk about standard form of a polynomial and what's called descending order and all that. First though, let's go over some terminology about the different parts of a number and about a monomial. First of all, the 7 here, that's called a coefficient. Everybody say coefficient. Okay, the coefficient tells you how many you have, how many x cubes you have. Well, in this case, there are 7. Okay, how many? That's what the coefficient tells you. The x refers to our variable or our base. Okay, and the 3 corresponds to the exponent here. Okay, another word for exponent would be power, and some people refer to that as the degree of the polynomial. In this case, it's degree 3, or a third power, or it says, you can say x cubed. Okay, the degree of the polynomial. So once again, the exponent refers to, the 3 refers to either the exponent, the power, or the degree of the polynomial. In this case, this is a third degree monomial. We're going to be talking about how to combine terms, and in order to do that, you have to know what like terms are, and this is a very key concept here. Like terms have the same base. Okay, by that I mean same variable. They also have the same exponent. Okay, or power, or degree. Okay, same exponent, same variable, basically. Okay, and that's important because you can only combine like terms. Terms that are unlike you cannot add. So this is going to be a very, very important concept here. These two things, here and here. Same base or variable and same exponent. There's some more terminology here, so let's go through it. A monomial, mon meaning 1, bi meaning 2, tri meaning 3 here, poly meaning many. Alright, a nomial right here meaning term or terms. If you put these together, a monomial means a single term, like the one above. The 7x cubed above here is called a monomial. It's a single term. That's basically all you have to know. If a binomial is the sum and difference of two terms. Okay, it's either a sum or a difference. Okay, either adding or subtracting of two terms. Let me give you some examples on that. One example of a binomial would be 3 minus x. That's the difference of two terms. Or x squared minus 4, that'd be another example. Okay, a single term would be 7x cubed or 8x. It could be 10, about negative 5, y, let's say y squared. Those are all monomials. If you add or subtract two terms, you call them binomials. Do the same thing for 3 terms, you call it a trinomial. So a trinomial is a sum or difference, okay, of 3 terms. Okay, a good example of that would be x squared minus 7x plus 1. Okay, 1, 2, 3 terms, adding or subtracting, doesn't matter. We call that a trinomial. In the standard form of a polynomial, an expression with many terms involved here, in descending order, okay, descending order looks like the following here. Again, descending, you have to know what that means. Descending means high to low. Okay, high to low. Okay, it goes like this. It sounds complicated, but I'm going to put it all together and give you some examples of it. Let me write it out. I'm going to start off with a sub n times x to the nth power, to the nth degree, plus a sub n minus 1 times x to the n minus 1, plus many terms, plus a sub 1, a sub 1 here, times x to the first power, plus a sub 0, which is your constant term, times x to the 0 power, where this right here is just 1. Anything to the 0 power is defined to be 1, okay, with the exception of 0, of course. Okay, so recall that. So I know it looks kind of fancy, but hey, let me give you an example. Okay, suppose you have 3x to the 5th plus 4x cubed minus 2x squared minus 8x plus 10. Alright, look at the degrees. We've got 5th degree, 3rd degree, 2nd degree, 1st degree. That's 1st degree right there. And if I put an x to the 0 power there, which equals 1 by the way, I get a 0 degree term for the constant. So that's in descending order, where the a's represent your coefficients and x represents your variable at different degrees. It's a 5th degree polynomial because the highest power is 5. Alright, so what we're going to do is we're going to reorder here and try to get polynomials in standard form first. Alright, so let's go ahead and do that. I noticed that looking at the powers, I got a 2nd degree term, a 4th degree term, and a 1st degree term. Alright, obviously that's your highest degree term. Okay, so I'm going to regroup the terms here. Reorder. That's what I meant. Reorder the terms, okay, from highest degree to lowest degree. From high to low degree. Okay, so I'm going to start off with a negative 5y to the 4th. The 2nd degree comes next, and it's positive here. Why? Because there's no minus sign in front. So plus 13y squared plus 3y. There you go. Take a look at the exponents. 4th degree, 2nd degree, 1st degree. Alright, that's called descending order. Descending order. Okay, make sure you do that on all polynomials and all results. Okay, here I've got 3rd degree. That's the highest. So I got a negative 5x cubed and then minus 13x squared. You got to keep the sign in front of it. Okay, 13x squared is being subtracted, so keep it subtracted here. 10 is positive right here, so add the 10. Okay, again, look at the exponents. 3rd degree, 2nd degree, 0 degree. Okay, on the part C here, we've got the highest one would be 5th degree, and it's positive here, so I got 13p to the 5th. Alright, and then my cubic term here, 3rd degree term, minus 2p cubed, and then 8p is being subtracted because it's negative, so minus 8p. Again, look at the powers, 5th degree, 3rd degree, 1st degree. Okay, this is 1st degree, and again, this is a 0 degree term. Alright, now let's talk about simplifying polynomials with regrouping involved. Okay, so let's take a look at this here. Number 2, we want to identify the like terms here, and the like terms have same base and same exponent. Okay, so let's identify the like terms here. Like terms, okay, 2 things, same base or same variable, alright, same exponent. You've got to remember that. Like terms, same base, same exponent, or same variable, same exponent. So let's identify them first. I see a 7x squared here and a minus 2x squared here. I'm going to regroup first. In fact, let me write that down. Regroup first. Alright, and then step 2, this is first and this is second. Then combine like terms. Okay, so it's going to be a 2-step process for these two. Alright, so here we go. We're going to regroup. We're going to switch the order here. Why? So you can group up the like terms. We're going to have 7x squared minus 2x squared and then minus the 8y. Okay, these are like terms. 7x squared minus 2x squared. It's got to be 5x squared because whenever you combine like terms, you always end up with the same term. It's kind of like adding apples with apples, you get apples. And combine oranges with oranges, you get oranges. If you start off with 7x squareds and you take away 2x squareds, it makes sense to have 5x squareds remaining, and then you got that minus 8y. And you're done at that point because these are not like anymore. Alright? On this one here, we have the cubic terms that are like terms right here, and then we have the x terms that are like terms. We'll start off with the highest degree, and that being the cubic term. So we have a minus or a negative 3y cubed minus 4y cubed, and then the x's, we got a plus 8x here, alright, and then we got a minus 2x here. And at this point, that's the first step. That's regrouping. Okay, now we have to add or combine like terms. Negative 3 minus 4 more is a negative 7. y cubed. Okay, yeah, when you combine like terms, you have the same term remaining. 8x minus 2x's is 6x, and it's positive, so we put plus, and write 6x here. So we're going to regroup and then combine. Alright, now it's not always that easy, so this time what we're going to do is we're going to kick in a little distributive property here. We're going to regroup after we distribute. Okay, so first, alright, distribute. Second, alright, regroup. Third, okay, you're going to combine like terms. Okay, so here we go. The very first thing is you distribute where it's needed. Okay, in this case, we're going to distribute to the -2. And make sure you keep track of your signs. So here we go. We're going to starting from left to right. So we got 13y plus 12x squared. All right, minus 2 times 5y, which is 10y. And then -2 times 13 is -26 x squared here. Okay, that's the first step. Secondly, we need to regroup. Okay, so let's group up these two terms here. Let's regroup here. Okay, so 13y minus 10y plus 12x squared minus 26x squared. Okay, there's my regrouping. Now I do the third step, and we obviously simplify or combine like terms, and we get 3y here plus 12 minus 26 is a -14. And so typically people write it as a minus 14x squared. And these are on like terms, so we stop after this point. Alright, so we're going to follow these steps here and do a three-step process. First distribute, then regroup, and then combine. Okay? So the first thing I need to do is distribute through the -1, and then I have to distribute through the -3. Okay, you can think of this as a -1 if you like. Right there. Okay, so, or just think of it as opposite as well. So either -1 or opposite. So -1 times 3y cubed is -3y cubed, or you can just take the opposite of it. -1 times 12 is -12, so minus 12y squared. -3 times 2y cubed is -6y cubed. -3 times 7 is -21 x squared. Step 2 is regroup. Here we go. Group up those two terms. Group up those two terms. Okay, so you have -3y cubed minus 6y cubed minus 12y squared because it's being subtracted minus 21x squared because it's being subtracted. Alright. Alright, and then combine. So -3 and a -6 is a -9y cubed. -12 and a -21 is a -33. So -33y squared. And that's how it's done through the whole thing. You want to distribute first, alright, and then regroup and simplify. So here we go. Let's try it again. 3 times 3y is 9y. 3 times 12 is 36, so 36y, x squared here. And you distribute through the -1 right there. You just think of it as a -1, or just negative. It will change the sign, so minus 5y minus 13x squared. A negative times a positive is a negative. A negative times a positive is a negative. Okay, regroup. It's going to sound like a broken record pretty soon because I'm going to repeat my directions over and over again. Hopefully you guys will get it after a while. So I got to regroup here. Keep the signs. Remember, 36 is positive because it's being added there. 13 is being subtracted. So, okay, and now step 3, we have to combine. So 9y minus 5y is 4y. 36 minus 13 is 23, so plus 23x squared. And you're done. Okay, so here we go. A few more to do. We're going to distribute through the 2 3 times. So 5y plus 2 times 3 is 6, so we got 6x squared here. 2 times -5 is -10y. 2 times 2 is 4, so we get plus 4x squared. Okay? And then finally, like terms, I see terms here. Now I'm going to group up the x's first. Why? Because it's alphabetical. Okay? So 6 and 4 is 10, so 10x squared here 5 minus, oh, I got to regroup. I'm jumping the gun here. Okay, so let's regroup. 6x here squared plus 4x squared plus 5y, it's positive, minus 10y here because it's being subtracted. Okay, now I combine like terms. 5 minus 10 is negative, so I'm going to put a minus sign here. Minus 5y. And that's all there is to it. I'm going to distribute. Alright, and then combine like terms. Or actually redistribute and regroup and then combine like terms. So negative 5 times 3 is negative 15, x to the 4th. Negative 5 times 12 is negative 60, x squared. Negative 5 times negative 5x is positive 25x. And then I've got that 13x squared or cubed remaining. It's a cubed here. Okay? So what do we have? This cubic term needs to be up in the middle here. Okay, so reorder, we get negative 15 x to the 4th plus 13x cubed minus 60x squared plus 25x. There were no like terms, so I just regrouped and reordered it and put it in descending order. Okay, from 4th degree to 3rd degree to 2nd degree to 1st degree. And then you're done. Okay, last one. We're going to distribute through the negative 2. We've got 13y plus 12y squared minus 2 times 5 is 10y. And then negative 2 times 13 is negative 26y cubed. This one jumps out in front because it's the highest degree. Alright, so what is this equal? Negative 26y cubed. That's a y cubed here. Alright, and then the y squared comes next, so plus 12y squared, and then plus 13y minus 10y, and these terms are like, so we got negative 26y cubed plus 12y squared. 13 minus 10 is 3, so plus 3y. And there you go. That's how it is, guys, okay? So try your homework, and I'll see you tomorrow.